Okay, so in this video, we're gonna solve a general system of linear differential equations given over here. So step one, as we've been discussing, is to set up the matrix of coefficients. So we'd have A is 12, minus 3, 3, and 6. Then we want to find the characteristic equation by taking the determinant of the matrix 12 minus lambda minus 3, 3, and then I subtract lambda from the other diagonal term, 6 minus lambda. So when I take the determinant of this, P of lambda is going to be the 12 minus lambda times the 6 minus lambda. We take our product of diagonal terms, and then we're going to subtract the off product of the off diagonal terms. So minus a minus 3 times 3. So grouping these terms together and solving, we get that P lambda is equal to lambda squared minus 18 lambda plus 81. And setting that equal to 0, we could factor that into lambda minus 9 squared. So here we've got one repeated real root, or one repeated real eigenvalue. So we're going to do the same thing in this case as we did when we had second order differential equations with repeated roots. We're going to say we have C1 e to the 9t plus C2t times e to the 9t. So our eigenvalue 9 was repeated. And y is going to have a similar form, some constant e to the 9t plus some other constant times t e to the 9t. And what remains to do is figure out how these constants C1, C2, C3, and C4 are related to each other. And we can do this by substituting these solutions, say, back into the top equation, for example, and solving for the coefficients C3 and C4. So I'll take a look at that on the next slide since we need a little bit more space. Okay, so we've got the top equation from our original system, and we have our templates for what our solutions for x and y look like. So plugging these in, x prime would give me 9 c1 e to the 9t, and then applying the product rule on that second piece over here, I would get c2 times the derivative of t, which is 1. So I get c2 e to the 9t plus the derivative of this, which is 9 e to the 9t times c2t. So there's my expression for x prime. I'm going to set that equal to 12 times x. So that would give me 12c1 e to the 9t plus 12 c2 t e to the 9t, and minus 3y. So now I'm going to also subtract minus 3c3 e to the 9t minus 3c4 t e to the 9t. And then let's find the relationships between our coefficients by grouping terms. So grouping the terms that have e to the 9t in them, but without the t in front of them, there's 3 of them. So on the left side, we've got 9 c1 plus c2, and on the right side, we have 12 c1 minus 3 c3. And what we want to do is see how is c3 dependent on c1 and c2. So I can solve this equation for c3, and that would give me that c3 is equal to c1 minus c2 over 3. And then to figure out how c4 depends on c1 and c2, we could group our terms that all had the t in front of the exponential piece. So that would give me a 9c2 over here, and then on the right side, we had 12c2 minus 3c4. And solving that for C4, we could see here that C4 is actually equal to C2. So they're the same value. So now my general solution, I can replace C3 with our expression that we found over here. So C3 is now C1 minus C2 over 3. And that's the coefficient in front of the e to the 9t. And then we add to that C4, which we now can just replace with C2 times t e to the 9t. So here we've got our general solution for y. It depends on the coefficients that we define in our general solution for x. And again, if you like finding eigenvectors, you could certainly do it that way. The advantage I have here is the kind of last three examples we looked at where we had two distinct real roots in example A. Example B had complex roots, and this example had one repeated real root, that the process is the same no matter how our eigenvalues shake out. So feel free to just kind of use our similar plug and chug and line up the coefficients method. Since this worked when we were working with second order differential equations, it works over here as well. So rather than force everybody to try and learn how to find eigenvectors if you haven't done it already, we don't need to do that. You're totally fine finding these general solutions in the way that I've outlined here. So the end of the slides have 3 more examples. I will write out the solutions. I am not going to make videos for those, since hopefully after doing these first 3 examples, you've got the right idea. I would encourage you to try and do the last 3 on your own, and you can check your work with the solutions in the slides.